Managing costs while running Kubernetes workloads can be quite the challenge, especially when it comes to scaling deployments based on a specific schedule. How can you configure your Kubernetes cluster to automatically scale your deployments and manage costs, availability, and performance based on a prescriptive schedule? We have deployment objects that can utilize tools like horizontal pod autoscalers. However, some workload patterns are not based on easily captured metrics and autoscaler configurations. Moreover, Kubernetes resources like jobs and cron jobs are both tailored to run to completion, making them unsuitable for workloads that need to run for a specified period of time. However, with a couple tricks, we can harness the cron job construct in Kubernetes to automatically scale our deployments based on a customized schedule, even scaling down to zero replicas. By running these deployments on autoscaling Kubernetes platforms like Google Kubernetes Engine, we can efficiently scale the underlying nodes and resources, reducing costs by only paying for workloads when they're actually needed. The key is to ensure proper service accounts and roles for a successful cron job that can scale up and down our deployment. We'll showcase these concepts with GKE, specifically GKE Autopilot. However, our approach employs Kubernetes native and standard mechanisms for deployments, making it compatible with a variety of Kubernetes environments. Starting in the console, let's set up a cluster to demonstrate this pattern and create the necessary Kubernetes resources. Once the APIs are enabled, we'll create a Kubernetes cluster with the default autopilot cluster option. The default setting will suffice, but numerous configuration options are available. Importantly, node pools and node pool cluster autoscaling are not present in these configurations. Therefore, our method only needs to scale the workloads themselves to realize cost savings. If using GKE standard or other lower level Kubernetes environments, ensure nodes have autoscaling to take advantage of the cost savings when scaling the workloads down to zero. GKE Autopilot charges per pod, allowing for direct cost savings during deployment scaling. With the cluster set up, we'll now use a Cloud Shell IDE to create our example resources, which illustrate this automatic scaling concept. In our IDE, we'll create a Git repository for our Kubernetes demonstration resources, which will be shared in this video's description. To begin, let's deploy a basic example deployment, such as a deployment using Nginx and a single replica. Configure your kubectl client with the get credentials command, then apply the resource to deploy it to the default namespace. As this is an autopilot cluster, initial setup may take a few minutes since the infrastructure and compute resources are not pre-provisioned. Google will handle this in the background on our behalf. And now that our deployment is running, let's go ahead and bring in our autoscaler. The autoscaler is going to use a cron job to decide when to scale up or down our deployment, and just as an example, we're running this on an every minute schedule. We're going to use the Bitnami kubectl image, and we want to match the Kubernetes version in our kubectl version. So in the Kubernetes page, if I click into the autopilot cluster, we see that this is running 1.25, and we want to match that minor version in our Docker image for kubectl. The latest of these images is version 1.25.11. Now this image does contain some pre-configurations on the entry point and command, but it's nice to be able to override these so you can have more complicated scaling commands. And if you need to further expand this, you could run multiple commands, as well as pipe commands into one another if you really need to. Now, to be able to actually scale our Nginx deployment, we need to make sure that this autoscaler cron job has the associated permissions. So we'll attach a service account called kubectl scaler, and we'll give that kubectl scaler permissions around deployments and deployment scales. The role binding ensures that the role is attached to our service account, and that's actually all we need. We could parameterize some of these things like the deployment names and have a more flexible approach for the replicas that we set. But imagine, for example, that we have a schedule where on Fridays at 5 p.m., we want to set the replicas to 0. And specifically, that cron job would look something like this. And then on Mondays, we could scale back up our deployment using a separate cron job with this configuration. So we would have 2 cron jobs and then only have our deployment running from Monday to Friday. In any case, just for demonstration's sake, let's have this run every minute and set the replicas to 2, since we currently have a single replica running for our Nginx deployment. Once we hit the minute mark, we can see our kubectl scaler ran and then has created another replica for our Nginx deployment. If we check the logs on this, we'll see the scaling command output. Again, to demonstrate, let's change this now to 0 replicas and apply to watch the deployment scale down to 0. And now we have 0 Nginx replicas and aren't paying at all for that workload. Also, while these show up in our kubectl get pods command, note that they're completed and we're not actually running and paying for a pod here. With this pattern, don't forget about your non-deployment resources. For example, persistent volumes and their associated data are unaffected by the scaling. This is a potential benefit for data retention, but can have a small associated cost. Additionally, redeployments of Nginx will override the replicas setting, whether applied manually or in a CI/CD pipeline. So be sure to account for this in your deployment workflows and cron job specifications. In any case, using this pattern and as many cron jobs as you need, you could have complex mechanisms for scaling deployments up and down, including to 0, so that you can manage cost, availability, and performance in a prescriptive, schedule-based way. We hope that this pattern proves valuable for you, and we'll keep an eye on the comment section for any questions. Thank you for watching, and please enjoy responsibly.